Hello, ladies and gentlemen. We're welcoming you today in this first technical presentation. Thank you for taking your time and being here today. My name is Adonis Matsouris. I'm the technical director of Salfo and Associates from Greece, and I'm also a member of the board of directors of the Europengineers. Before moving to today's presentation, just allow me to say a couple of words about Europengineers, in fact, about us. Europengineers is a group of companies, a European network that was formed back in 1963 in Paris, already 60 years old. Okay. And as I already said, it's a European network of independent engineering and consulting companies. At the moment, Europengineers consist of 8 companies from 8 different European countries. It's Aronsohn from Holland, it's Basler and Hoffmann from Switzerland, Idea from Italy, Ondio from Spain, Road from Ireland, Salfo from Greece, Schüßler-Plan from Germany, and CETEC from France. The goal of the Europengineers is mainly to promote innovation, to grow the engineering sector by sharing information, know-how, and work together among each other. The CEOs of the companies meet regularly, at least twice per year, and exploring opportunities or identifying new trends, share best practices, etc. And within this framework, we decided last year to start a series of, we call them cross-company technical presentations, in order to ease and accelerate the information and knowledge sharing among all companies and all employees of the companies, in fact. So here we are today. It's the first presentation starting now, and will go up until the end of the year on a monthly basis. Today's presentation will be done by Mr. Michel Samp. It's the CEO of Aronsohn Consulting Engineer from the Netherlands. And the subject of the presentation is measuring building circularity and sustainability. And I suppose Michel will present us some assessment tools that are used in the Netherlands. Just before letting Michel step in, I would just like to inform you that we'll be, at the end of the presentation, we'll be running a live Q&A session. It will last about 20, 30 minutes maximum. So if you have any questions, just pop them on the chat on your right. In order to proceed to the procedure after the end of the presentation. Just a request from you, before posting your question, just add the company you're working for in order to ease the procedure. So this is just from my end. Thanks again for being here. So, Michel, I think it's all yours.
The
Excuse me, you're on mute.
Still muted. Yeah.
Miss.
Old mistake. Thank you, Antonis.
Okay.
Before we start, I would like to tell you that we are recording this this meeting, so we could share it to the other members of the other employees of Europengineers. So please yeah, if you don't want your face on screen, turn your camera off, and please also turn off your microphone so that I can do the presentation. There will be time to, there's a possibility to enter your questions in the chat during the presentation, and of course afterwards we can do that by live with the microphone on. But please use the chat. We'll first kick off this meeting, so this session of this series of lunch meetings. When I was thinking about the topic, the first thing that came up to me was circularity and sustainability. It's a subject that is very has very much attention in the Europengineers community at the moment. We had a seed meeting in the sustainability meeting in Paris in 2020, just before the corona. And when I talked to Michel Cahan from CITEC a few months ago regarding someone with a master thesis about what is done in the Netherlands about sustainability and especially in legislation, I noticed that it's different from at least from France. So maybe this is a good opportunity to show what you can do to measure sustainability and circularity. So that's basically what my presentation is about. I have two screens, so I have to click on the right one. Something about me. I'm one of the partners owners of Aronsohn. I work here since 2000. Before that, I worked for another company. I'm a structural engineer and also still a structural consultant within the company. So I do the managing part as well as the engineering and consulting part. So some short introduction about Aronsohn for you who don't know Aronsohn. We're active since 1927. We started out in structural engineering in Rotterdam. Since 1990s, we also do project management. We have our main office is in Rotterdam, but we also have an office in Eindhoven. We have about 45 employees. I think we're the smallest company in the group. We focus mainly on buildings, both project management as structural engineering, and structural engineering is within all materials and structural types. So as I said, we're mainly active in the Netherlands. We don't go abroad. Also a bit different from the other partners within Europengineers. I will show you some recent finished projects. We've done a lot in these 95 years that our company is old, but the most recent one are these were delivered last year, and even some this year is an academic hospital for in Nijmegen. We've done one of our main fields of expertise are hospitals. We did 3 or 5 academic hospitals in the Netherlands, but also some smaller hospitals. This one is a museum, but also a center for biodiversity. It's the Naturalis in Leiden. If you go to the Netherlands, you should visit this one. If you're in the neighborhood, it's close to Amsterdam, also close to Rotterdam. Offices, headquarters of Booking.com in Amsterdam, delivered a few months ago by UN Studio, 40,000 square meters and in total 100,000 square meters of parking garage, residential buildings and an office that you see on the picture. And a bank, the Triodos Bank in Zeist. This is a timber structure. This is one of them. It was already one of the most sustainable buildings in the Netherlands. It is surpassed by different buildings at the moment, mainly because they're built in wood and timber. Some facts and figures about this building, which will come up later as well. It's a lot of wood, but it's also because it's supposed to be remountable, but it's put together with 165,000 screws. So you can think about disassembly when you have to unleash all those screws. So what are we? What is mandatory in the Netherlands regarding sustainability and circularity? The government has set goals, and we want to transfer the entire economy to a circular economy, and that has to be completed in 2050. And this means no waste after that year. and we should be halfway around 2030. We're at the moment in 2023, and I'm not sure if that's one of the questions where we are at the moment. The basic principle of this policy is that we use it at R10 philosophy. Maybe it's known in the other countries as well, but it's a way to think about circularity. So with R1 to R10, R10 is dumping and landfill. The higher the number, the lower the number, the better the circularity. So the first one is refuse. Maybe we shouldn't build anything at all. Rethink is can we do things smarter, and reduce. If you build something, try to do it at minimum material as possible. What we're talking about are the numbers R3 till R7. R8, of course, is also one, but that's recycling, putting steel beams. It's the worst form of reusing, because it's bringing a steel beam to melt it down to make a new beam. But you can imagine that reuse a product or a component in a building without adjusting it is the best way to do. And the R4 between until R4 to R7 are different grades of reuse, with adjusting the product a bit or more. What sustainability goals have landed in the building code? So the code that we need to meet to get a building permit. The first one is energy consumption. I don't want to say too much about it because it's not my field of expertise. But for the people who are in MAP, new buildings, they have to be BENG buildings. BENG stands for almost energy neutral building. Bijna energie-neutraal gebouw in Dutch. And this means that for residential buildings, the energy consumption must be maximum 25 kilowatt hours per square meter GFA per year. And for normal buildings, it can be double. You need to determine the amount of primary fossil energy, and you have to have a minimum percentage of renewable energy, 50%. Most of the time, it's PV panels in nowadays practice, but also energy from windmills or other biomass, for instance. For existing buildings, there's a energy label, mandatory, but not going into that one. And if you look at material uses, and that's where we, as a structural engineering company, come in, and also a project management company come in, is that we need for new residential buildings and offices. The other buildings get their own requirements later, is an MPG of 0.8, and I will explain later what that means. But MPG is key and stands for the environmental. Oh, I see there's a typo. Impact of performance of buildings. So it's how good does the building perform on a sustainability level. But in 2030, this should be 0.5, and there are even that are even the wish to bring it back to 0.3. The MPG is expressed in shadow cost per GFA per gross floor area per year. To get a bit of a picture, a rough picture about what this means, is that the MPG of 0.3 means that the building should be entirely made of wood, except for the foundation probably, but the bio-based materials. Otherwise, you're not going to make it. So shadow costs are actually the costs to express the sustainability, and these are the costs to prevent environmental damage. So what if you make a door, for instance, or a steel column? What's the environmental impact on of making that column and bringing it to the building site, construction site, and to demolish it? It's expressed in the MKA. It's a unit per kilogram or meter, and you need a life cycle analysis according to a European standard. That number, and you also, with that life cycle analysis, you can produce an environmental product declaration, also according to an European standard. So there are European standards already which you can use to determine the MKI. You can imagine that all these products or materials you need an MKI. That is what we have done a few years ago. I think already 10 years ago is that we made a database of all these products and their MKIs. It's called the Nationale Milieu Database, the National Sustainability Database, roughly translated. And what it does is that a company, a supplier that has a specific products produces an LCA and EPD and enters it into the environmental database. You can use that number together with the amount of that product you need in a building to determine the impact of the product. Therefore, we have calculation tools. We used shortly BIMPACT, and what it does is that it's a calculation tool to determine the MPG. Some remarks on this national on this database, because the database is not complete. This has a few reasons. The Cat 8 and Cat 2 materials, they require an LCA, and that costs money. And many suppliers don't have the intention to make that to spend that money on their on such an LCA. So most of the time we're working with Cat 3 materials. There's no LCA, and this gives a very generic. That is a generic value. But it's also a conservative value. So if you have a building with only Cat 3 materials, the MPG score will not be as good as you would, even if the same material has with the same sustainability performance, and it has an LCA, it will score automatically better. So it's a sort of an incentive for suppliers to perform these LCAs and EPDs, but the suppliers are still very reluctant to do so. This gives a bit of a problem during a design stage, because we work with an incomplete set of data to determine the MPG of the building, of a certain building. But getting back to the wish to get in 2030 a MPG lower than 0.5, we actually require more or even all the products that they are in Cat 1 or category 1 or 2. Otherwise, you can't make the MPG of 0.5 as well. This MPG is also used in different certificates, just as the BREEAM. I think, well, BREEAM is internationally known. GPR is a Dutch standard. But for instance, if you want to achieve BREEAM Excellent for the credit, and you need a certain amount of credits for Mod 1. This means that you need an MPG less than 0.6, but also 40% of these materials in the MPG in your building need to be in Cat 1. So this is quite a serious demand to get the points. In this case, for BREEAM, we're focusing mainly on structure and building components. Of course, there's also an element of managing and health and all that part, but we're mainly focusing on the building materials at the moment. And another thing you can do to get the result in the BREEAM Excellent to gain the points, enough points for Mod 1, is to put it in a Madaster. It's a building passport. It's a database where you can put in the building and where someone in future times can harvest the elements from your building. So he knows if you have put the entire building in a database and someone and it's going to be demolished, someone else could harvest the materials using the database from your building. I'm not going into that any further. I could explain later if there are any questions about it, but it's not the focus of this presentation. And this is an example for the City Hall in Amersfoort. It's a project we're working on at the moment. It's in the tendering stage. It has a GFA of about 20,000 square meters. The lifespan is brought to 71 years, because the MPG is the total amount of MKIs divided by the lifespan of the building and also the GFA. And I hope you can read it. Maybe you need a bigger screen, but well, the building is a substructure of cast in place concrete and a superstructure of mainly cast in place concrete slabs and steel structure, partly steel structure with hollow core slabs. But the MPG of this building is 0.87. And you can see that the structure, if you take a good look, you can see that the structure is about 41% of the total MPG score. So for us as a structural engineer, the impact of what we do and how we design the building on the MPG is quite big. And they're always looking at us, of course, if they want to bring down the MPG. But as you can see, that in cast in place concrete is not really the thing to do when you want to lower the MPG. Another example is a building with a very high BREEAM score. They need 94% BREEAM. That's about as outstanding as it can be. So that means that the MPG of this building should be lower than 0.6, and 40% of it should be in category 1. It's a substructure of, and that's mainly the basement of a cast in place concrete, and the superstructure is a steel structure with hollow core slabs. It's not very big, but this has a MPG of 0.49. And what you can see is that what they have done, because to lower the score, is to extend the lifespan of the building. So 64 is not really a common lifespan for a building. Structurally, it's 50 years as a reference period. But it's a kind of a trick to lower the score. And also here, what you can see, even on the low score of 0.49, that 32% of the structure is structure in the total score. So again, for this building, the amount of the structure has a very big impact on the total score. So this was about the MPG, and these MKIs will come back in quantifying this assembly potential. For this, we are using a publication that is based on a thesis, a master thesis of someone in the Netherlands, and this goes for materials or elements that are delivered on construction site. So we don't have to. We only look at elements that are delivered on the construction. So a full facade element with the mullions in it and the glass. You can see that as one element, and it's the number of the result of the calculation that can be used in a BREEAM and a GPR score. GPR is also sort of certification type. The disassembly potential is divided in 4 different aspects. This is in Dutch. It's not translated because that was a bit too much of my time for the last day. So I will try to explain it in English and translate it while I'm talking. The first one, of course, is the type of connection. If you look at disassembly, you can score the highest score is 1, the lowest score is 0.1, which you can achieve. But if you look at the type of connection, the highest score you can get with magnetic connections or click connections. Sorry. I'm going too fast. A bit lower are the bolted connections, or with connections with screws, but connections that you can easily undo. The next category are connections with nails or dowels, for instance. You need some extra effort to disassemble. soft chemical connections like kit or foam, polyurethane foam that is used also in the Netherlands, and you have these hard chemical connections. That's the lowest in the score. That's about gluing, welding, cementous chemical anchors, cast in place concrete. So that's the lowest score. The next one is the accessibility of the connection. So you can score the highest points if you can easily access the connection. So if you don't have a ceiling and you can see the structure immediately, for instance, then that's the highest score. And when you go down, it takes more and more effort to access the connection. So it is with if you can recover the damage completely, if you can partly recover the damage or repair the damage, or if you can't repair the damage, if you put the connection behind plasterwork, you have to demolish the entire plasterwork. So it's the lowest score. Next ones are crossings. If an element is crossed by another element, and it takes an extra effort to remove the crossing element to disassemble the original element, you also get points. So we have no crossings and fully integrated crossings. I have some pictures later on to show you, to give it as an example. Then we have the confinement of the element. So if the element is confined within other elements, and it's uneasy to or easy to extract, then you get also points. Yeah, so for instance, if you look at type of connections, you can see that if we go to the left bottom, you see a steel structure, bolted, easily accessible. So that scores very high. In the other way, it's about roof covering. If it's not bituminous, but it's mechanically connected, then you score higher. And even so for a tapestry, and of course the connections in wood, the pin connections, they are better than, for instance, these kind of connections: gluing, kitting, pouring, and spraying. These are all bad scoring types of connections. Accessibility, as you can see, these wooden girders are easy to access. So this is a relatively high score. You can dismantle these beams without any problem. So this is a good one. And this is the same project, but a different floor. These are the HVAC installations are on the floor, fully integrated in the floor. And these are quite difficult to access, because you have to remove the computer floor, you have to remove all kinds of other stuff to get to the ducts and change the ducts. So this is a bad scoring element. When you think of crossings, you have things like this. You have for instance, a wooden slab, and the MEP is fully integrated in the floor itself. And if you have to make a change to these MEP installations, then you have a big problem, because it's very it costs a lot of time and effort to change them, to remove them. On the top right, it's a bit less serious, because these are incidental crossings. But still, you have to remove. What's important in these crossings that we have to work with the layers of brand. I'll get back to the layer. So I'll get back to that later. And the last one is confinement. How easy is it to remove an element which is lying in other elements? So if you can pick it out without any problem, you can lift it out. So as in the top left, then you get the highest score. And the second one is if it's confined on one piece, on one part of on one edge of the element. And in the right top, you can see that's completely confined. Even if you have a hollow core slab, floor with hollow core slabs with hollow core elements, and the joints are filled with concrete, then you have to see it as a fully closed element. So it also scores very the lowest points. If you have these per element, these 4 scores, then you should add them up according to this formula, and you get the disassembly index per product. And if you take all these elements together, you have to weigh them with the MKI, and that's where the MPG comes in again. You have to weigh them so the elements with the highest impact on the MKI, the MPG, have the most impact on the total score, the total disassembly score. And what you do at first, you calculate the disassembly index per layer of brand. Maybe people know the principle of these layers of brand, but a building is divided in several layers. Structure is one of them, but also the skin, the facade, the surfaces, MAP, the space plan, the non-bearing walls, the office furniture and stuff, and the people, of course. And if you keep these layers separated, because all these layers have a different lifespan, the structure has the largest lifespan, then you can remove these layers easily without interfering with the other layer. And if you, in the end, if you put all these layers together and with the MKI score, then you have the assembly potential of the entire building. If you look at the structure, or the core and shell of the building, it's how you want to call it. For structural elements, the highest feasible value is about this one, because well, we're not used to gluing, or we're not used to using magnets to keep our beams and floors together, slabs together. So the bolted connection is well the least we can do. So 0.8 is the maximum score. Accessibility and crossings, that we can manage with the other parties, but also the confinement for structural elements is quite complicated to get a higher score than 0.4. So that's so it's good to realize that for structural elements, which should have a certain integrity and durability, that you don't going to manage a higher score than 0.7 per element, and also because of the way of calculating. The lowest value, of course, has the highest impact. So you want to keep as far away as possible from the 0.1. But for a concrete slab in situ, well, it's quite hard to keep it from 1.1. So also it's because it's this way of calculating is for all these building elements way too much work. So what they do from a practical point of view, they only take the elements with the highest impact. So, for instance, the structure has a high impact on the MPG. So you can look at the structure for a facade element which doesn't have a really high impact on the MPG, or the facade in total which doesn't have a high impact on the MPG. You don't have to take it into account. So, in the end, you see that there are only a few elements with a high impact on the building, the assembly potential. But what they also do in the GPR, that's like BREEAM, another way of certification. They also combine it with reuse potential. That's quite interesting because they also look at because it could be very easy to disassemble an element, but if you're not going to use it, there's no point of disassembling this material, do anything about it. So this is also a nice a practical addition. So I'm about to end the presentation. So at the moment, because all these things come together in this project, together with an architect and an MEP advisor, we have won this project, tender of this project. And they're aiming for an MPG of 0.5, and also 40% of the material should be in category should be in Cat 1. This assembly potential of a bit larger than 0.4, and also 30% of the reused of the material should be reused. So this means for sure that if we're gonna meet with these requirements, then we're gonna need timber floors, laminated timber trusses and columns, and also concrete with reused aggregate and low carbon cement. Otherwise, we're not going to manage to reach the 0.5. That's about it.